Good morning.
Good morning.
All right. I just want to jump into code examples. How is the homework going so far? Okay, I think that silence tells me what I need to know. Let's see. Here's what I'd like to do then. Let's take a step back. And whoops, I need to share my screen. I'm sorry. Okay. Let's take a step back and start with something fairly simple and work our way through again. So let's do just good old search, right? Given a list of integers and a key, return true if the key is in the list and false otherwise. And I think we did this the other day, but repetition is not a bad thing. So first, let's just define some lists. Why are you going? So there we go. That's L0. Well, let's let L0 be the empty list. It's always good, to have the empty list to check to make sure that you are, you're not missing these perverse cases. It's good to have some repetition. One last one. Zero is nice to try. Negative numbers are nice to try. All right. So once you make your lists, these are basically test cases. Make sure that they actually took. Okay, so the goal here is given a list of integers and a key, return true if the key is in the list and false otherwise. How would you approach this? How would you approach it in the imperative world? What do you do?
Take a key and then traverse through the list, and if the element doesn't equal the key you're looking for, keep going until you find said element.
Exactly. So, and that's an iterative process, right? You start at the front, you'd store it in an array, and then you start at the beginning of the array, and you keep check, just going down the list. And what happens when you're at the end of the list and you haven't found it? You run out of elements.
Would you return null or zero, I guess, depending on which one?
Yeah, and in this case, we're specifically returning true or false. So, right, so we're going to return false. Yeah. Bryce, you're right on the money. So what we're going to do is basically say, look, if it's in this list, it's either I'm going to check the first element. If it's the first element in the list, I'm going to return true. But other than that, I'm going to check the rest of the list. And we would do that with recursion instead of iteration. The thing to think about with recursion is what happens last, right? What's the last check you make? What situation are you in with the last check? And one way to think of it is usually you're going to have a list that is either empty or has one element left. And since I want my function to be able to handle empty lists, I'm going to check to see if the list is empty. So I'm going to define search to be a function that takes in a list and a threshold. And I always do this to make sure my parentheses, I have a better percentage chance of having the parentheses match up. Let's put it that way. So the first thing we're going to do is check to see if the list is empty. Notice how often this comes up. And if the list is empty, we're going to do something. And if it's not empty, we're going to do something else. Now, if the list is empty, what did we say we were going to return?
False.
Right. Right. So if I gave you an empty list and said, hey, is the number 12 in this empty list? Clearly the answer is no. Right. Clearly the answer is false. Then we're going to do, okay, it's not an empty list, so let's check. And what we're going to do is check to see if the first element matches the I want this to be key, not matches the key. And if it does, great, we're done. True. If it doesn't, then we'll just keep recursing. So if, and this is going to be our conditional, that's our true branch, that's our false branch. And what are we checking? We're checking to see if the car of L is equal to the key. If it is, if the car of L is equal to key, then we found the element, right? And we should return true. If it isn't, we just keep performing this operation on the rest of the list. So we would search the rest of the list using the same key. I feel like I have too many. I feel like I screwed up my parentheses. There's my conditional. There's my if statement. There's my other if statement. Ah, there we go. There's my other if statement. There's my lambda definition. There's for lambda, and I still messed up somewhere, so let's put that in there. Let's see if I got any errors. Okay. So if I did search L0 for 5, it should return. See, I do have a problem. Does anyone see it? Yeah. Given application, not a procedure, except a procedure given applied to arguments. Given F arguments none. Wait a minute. Some of my problems here. Oh, I've got, that's not right. That's what's wrong. Okay. Yep. You're right. Okay. If pound. That's that. I'm going to have one too many. So okay, that's what it was. I put an extra if parentheses in the front. Okay, let's try that again. L05 false. Search L15 true. Search L35. Okay, so it looks like it's working. Now let's modify this slightly. First of all, I'm going to save this. Oh no. Oh, that's horrible. I just wiped out my other example, the point cloud example. Very clever. Okay. All right, now let's do a different one. Let's do this count if equals. So basically, if you're familiar with Excel, there's a countif function, and you can specify some kind of a parameter, some kind of Boolean parameter, and or conditional, and every cell within a range that meets that conditional, Excel will just count that up. So instead of just returning true and false, let's return how many times the key shows up in the list. Now, if the key doesn't show up in the list at all, we should return a 0. And other than that, we would return how many times it shows up in the list. Okay. So how would you approach this? It's going to be very similar, right? How would you approach it? If I asked you in the imperative world how you would approach it, you would be able to do this simply, right? How would you approach it in the imperative world?
You could just run through all of the like the whole list and then just have a counting variable.
Right.
How many times you see it.
You would have a variable like called sum or total or something like that, and you'd initialize it to 0, and then you'd iterate through the array, and every time you saw a match, you would increment the sum, or you would increment the total. So here it's a little bit different, because we don't assign to that little helper variable, right? So instead, what do we do? And this is the part where recursion, when you start to think recursively. Well, let's see. First of all, what's the last thing we're going to look for? If I give you an empty list, what should the result be?
Zero.
Should be 0. Return 0. Otherwise, right. So otherwise, we say, okay, if it's not a null list, then we say check the first element against the key, and if it's true, we're going to do something. If it's false, we're going to do something. If it's true, instead of incrementing the sum, how about we increment whatever number we got from running this on the whole rest of the list? I'm still calling it search. I should call it something else. Otherwise, we would add 0 to whatever we get from the count from the rest of the list. I need a key in there, don't I? Okay. But adding 0 to something doesn't make much sense. So I can just say, hey, it's whatever's the rest of the list. Whoops. So what's happening here? Let's take this. If I took this one and I said, okay, I'm looking for a particular value, and I'm going to count how many times that value shows up, then let's say the value is 42. Wouldn't it be 1 plus however many times 42 showed up here in the rest of the list? Or if the value is 54, when I check the first one, it would be 0 plus whatever I got from however many times 54 showed up in the rest of the list. And then once I check this cooter list, right now I'm checking the smaller list. Since 54 matches, it's going to be 1 plus however many times 54 shows up in the rest of the list. And you keep doing that and doing that and doing that until you have an empty list. Clearly 54 shows up 0 times in the empty list. By the way, I'm going to save as, right? Remind me to save as. So I don't destroy our old things. Okay, there we go. So that's the thinking. Now, one of the things you have to do is match. Remember what you're returning. Since we're returning a numeric value, when we get down to the end case, we want to return a numeric value. And then we're going to perform along the way mathematical operations that perform a numeric value. And the reason I'm stressing that is right now, like the first time we just returned a Boolean value and a single Boolean value. We didn't have to keep track of anything. We got true or false. And if we found the key, we got true immediately. And once we reached an empty list, we got false immediately. Here we're actually doing a little bit of aggregating, right? Because we have a numeric value, but we're constantly increasing, potentially increasing that numeric value. The trick is the only difference between this and the imperative way, really, number one is we're using recursion instead of iteration. And number two, we don't have that little helper variable of sum to store the current number in. And the reason is we don't need it. The current number is whatever I get from the rest of the list. I'm not a fan of this helping, by the way. It's helpful when you're coding sometimes, but not when you're talking about it. So let's see if I did this right. COUNTIF L0, and let's look for 54, and we get 0, and COUNTIF L1 54, and we should get undefined. That'll teach me to capitalize. See, so we do have an issue here. Oh, gosh. Simple one, right? There we go. Keeping track of parentheses. There we go. I should be able to try them all. I'm not sure if I have my syntax right. Oh, I'll list myself. Okay. Never mind. Let's try L4 and look for 54. Now what? I did the same thing. That doesn't encourage you when I do that, does it? There we go. There we go. And is that true? It showed up 3 times there. It's 1, 2, 3 there, and that's the only time it shows up. Gosh darn it. We have 1 -10, and we should be able to get something that doesn't exist at all. And we should always check against the empty string, empty list. Okay. So do you believe it works? You see the pattern. You always look at what's the thing that's going to happen last. That's the way I approach this. What's going to happen last? And what's going to happen last is we have an empty list. And then what should I return with an empty list? Well, keep track of what is the thing that you're returning. I'm returning a numeric value, therefore I need to return a numeric value. When we did the search, we were returning a Boolean value, so I had to return a Boolean value. Now, all of these are really simple so far. We're not building functions and building functions yet like we did the other day. We'll come back to that. Okay, so let's save these. Okay. Instead of that, let's do the filter, which I think we did the other day. We'll return the list that has all the integers that are greater than the threshold. So before I forget, I'm going to save as. And instead of key, I'm going to call it T for threshold. Notice how the structure is going to be the same. I'm going to check for a null list. Now, if I have a null list, what I'm doing is I'm giving a list of integers, and what am I getting back? I'm getting back a list of integers, right? So if I fed a null list into this, if I fed an empty list into this, what should I get back?
Zero, right?
Are we counting or are we returning a list? Which is a nice way of saying, no, that's not right, Miles.
Okay.
Right, a null list, because if we're returning a list, now this is where, again, this is not a language where you need to explicitly declare your data types, which means you need to keep track of it. And sometimes it's difficult because, okay, am I returning a number? Am I returning a list? Am I returning a list containing other lists? You have to keep track of that. So if I said, give me a list, I'm going to give you a list, and you're going to return a list of every number that contains every number greater than 10. And I give you the null list. How many numbers are greater than 10? As Miles said, it's 0. Therefore, how many elements should be in the list that gets returned to me? 0. It's a null list. None of them are greater than 10. Now, what if it's not null? Let's see if I get this right. If it's not null, then we check. And if the car of the current list is greater than the threshold, what should we do? What are we returning? We're returning a list, right? So if the car of the current list is greater than the threshold, what should we do? Greater than car list. I remember the parentheses this time. Return the value appended to the function call. Yes. And so what we're doing is returning a list. We're going to add it to the list. Add it to what list? The list we get when we run the function on the rest of the list. So I'm going to do cons RL filter. No. Footer L threshold. That's that. Okay. Now, did that make sense? So if let's take this list here. I'm going to return all the values bigger than 50. So I first check 42, and it doesn't meet it. It's not greater than 50. But then I check, so now I'm dealing with this list that starts with 54. And so now I'm going to check 54. It is bigger than 50. So what should I do? Eventually, I'm going to return a list that has that 54 in it. So I need to take that 54 and add it to the list that I get from the rest of this list. And then the same thing with 67. I'm going to add that to the list that I get from running the function on the rest of the list. The same with 89. How about 12? I don't add it at all, right? So the list that I'm returning is just basically the function that's run on the rest of the list. So I'm just going to do filter, recruiter, L, threshold. That's that, that's that. Let's see if I have my parentheses straight here. Filter L0, 10, and I get the empty list. Filter L1, 10, and I get the empty list. Filter L1, 5, and I get the list that's greater than 5. Oh, 70. I get 89 twice. Why did I get 89 twice? Because it's here in L4 is all the lists put together, right? It's here in L2 and it's here in L3, so I got 89 twice. Notice this pattern of what do I do at the end? What do I do when I'm at the end of the list? Now here I'm always checking for the last element. There are times when you are going to check to, you might have a list of length 1, like you're checking the last element rather than checking for an empty list. Or in a case where, let's say I was doing a list of numbers and I wanted to tell you how many times one number was greater than the next number. How many times did that happen? Well, if I ran that all the way down to a null list, it's not going to work because I can't get a next number, right? I'm going to get an error. It's like running off the end of an array. Or if I even go to the last number, it won't work because when I'm at the last number and I ask for the next number, there's no more numbers in the list. So that's no good. So I would have to check to make sure that my list was at least of length 2. So I have a number with the next number. And that would be my end condition. Now to do good programming, you would still wrap that in a situation where, hey, what if you got a list that was less than 2? You know, you should call that a perverse case or something like that. Maybe we should do that. Now, what if I wanted to do this? If I'm given a list of lists in a key, return a list containing each that contains the key. In other words, if I was given, in this case, well, let me go back to my notepad here. If I was given a list that contained L0, L1, L2, and L3, and I said, okay, if the list contains the number 5, give it back to me. Would L1 be in that list? I'm sorry, would L0 be in that list? Would L1 be in that list? Well, 5 is in L1, so L1 would be returned. And L2 does not have 5, but L3 does have 5, so that would be what's returned. Let's be more. Does that make sense, what I'm asking? We have a list of lists and you give me and I say, okay, give me all the, give me back every list that contains, some number greater than 5. This is similar to, what if you have like an employee database and you have, accountants and you have managers and you have engineers and you have contracts people, and in the database, they're all listed by their job type. Couldn't you ask that database, hey, give me a list of all the accountants that work for our company? And it would give you all the accountants back. But really, what's it doing? A database is going to have for every individual employee, a whole bunch of fields, person's name, birth date, job title, salary range, whatever. And so really what you have is that would be a list, and the entire employee database is a list of lists. And then when you say, hey, give me all the accountants, you're going to get returned the list of accountants, but since each accountant has its information in the list, it's a list of lists. So that's what I'm saying here. Given a list of lists, return the list that contains all the lists that meet that criteria, that meet some criteria. In this case, it just contains the key. So first, let's see, let's get search back. We're going to need that. Yeah. Yes, that's right. So I'm going to define L5 to be a list composed of L1, L2, L3, and what the heck, L4. Let's make sure I did that right. Notice how it's a list of lists. What did I call this thing? These are horrible names. Filter list. We're going to bring in a list, which is really a list of lists, remember. And we're going to bring in some key. And now we're returning a list of lists. So let's see, every time we return something, it's going to be an element of the list. I don't know how to specify verbally, like the list of lists versus the list, right? Same trick. We're going to try if the list is null, we should return the empty list. Otherwise, well, let's see. If the list is not null, then what we need to do is check to see if the thing we're interested in is in the first list. So if I'm looking for 5 and someone gives me this, if I'm looking for the value 5, right, I'm going to say, okay, I'm going to give you a list of lists. You just tell them, give me back all the ones that contain 5. Well, what's that? In terms of the list of lists, the car of the list of lists, now at this point, is a list, isn't it? Isn't this what I have highlighted, one element in the list of lists? So when I car the list of lists, I get that list, 1, 2, 3, 4, 5, 6, 7, 8, 9. And since that 5 happens to be in that list, then we should add it to the list that we're bringing back. But instead of just adding a number like we did last time, we're going to add this list. So we're going to check if, well, now what do? We have a search function already built up. We're going to run it on the car of the lists with the key. If it's true, we're going to do something. If it's false, we're going to do something. If it's true, we're going to do just like we did last time with the integers. We're going to take that and add it to the list that we're building. And we're going to add it to the list that we're building by consing it to whatever we get when we run filter list on the rest of the list. And if it's not there, we don't add it. So we just do filter list on the rest of the list. I was going to say, if I got all those parentheses right, I'd be shocked. There we go. There's my Boolean. That's if it's true, that's if it's false, that's that if, that's that. I'm missing one and that makes me suspicious. We'll find out. We'll find some you. Because I'm running this on filter and I wanted to do the whole thing on search. There we go. Let me cut that whole thing over. Come on. There it is. Okay. Let's try that again. Okay, so if we do filter list L5, and let's look for 5, we get back all the lists that contain the number 5, which is L1 and L3 and L4. Does that make sense? Or what doesn't make sense? The thing I want to point out here, this is search. I better save this as and I better fix filter before I screw it up. There we go. Okay. Okay, what's confusing here? Notice once you start to get into, I have a list that contains other lists, in your head, it may be difficult to keep that straight. And this is a typing issue, not my bad typing issue. it's a data type issue, right? Since the language does not require you to explicitly declare types, you have to keep track of that on your own. The other thing I want to point out about this particular example is, as we start to do more complex things, you never want to do it all in one function. You want to create smaller functions that then become building blocks for your bigger functions, and you use function composition. So we already had a search function, which, by the way, I absolutely am certain we wouldn't have had to build, right? I'm sure it's supported directly by Racket, but it's a good example for class. And then we use function composition by using that helper function inside of another function. The file that I destroyed about half an hour ago was an example of that, where we go back to that point cloud example. But we'll do more point cloud examples on Friday. Hopefully some of this is starting to be, first of all, reasonable, and maybe habitual. Again, when you see these patterns over and over and over again, look at that pattern, just keep showing up over and over and over again. Hey, am I done with my list yet? No? Okay, then I have to do some stuff. And what am I going to do? I'm going to do something to the front of the list, and then I'm going to call my function recursively on the rest of the list. Notice how that keeps showing up over and over and over again. If I am at the end of the list, I have to perform some action or return some value, but I have to make sure that the value that I return is consistent with the thing that I'm trying to get out of here. If I'm trying to get a Boolean, that better be a Boolean. If I'm trying to get a number, that should be a number. If I'm trying to get a list, that should be a list, probably the empty list. Okay, I'm not going to get into the next example yet. So do we have questions before we go? That website, Beautiful Racket, has some good help. I think really good documentation, and some of the examples are good. By the way, I guess before we go real quick, if you were to build search in a normal programming language, that's a biased statement, I shouldn't say that. Some people grow up on this stuff. If you were to go to get your computer science degree at MIT, the first programming class you have would be in Scheme. And there's two reasons for that. One is the guy who wrote Scheme was a professor at MIT. The other is that there is a strong argument that it helps with computational thinking. Let's see, int L equals new int and 10. I'm not going to worry about initializing it. We want to do search. Technically, this should be. Right? There. But we wouldn't do it that way because you shouldn't have you shouldn't have two return statements. So we would do, gosh darn it. We would do that, and this would be changed to and we wouldn't have an else loop. And then something like that, right? So our search here is what, 1, 2, 3, 4, 5, let's say 6 lines of code. Our search here is 1, 2, 3, 4, 5, 6 lines of code, roughly. No change in size. Notice how you're doing the same thing though. If you get to the end and you haven't found the key, then you return false. Otherwise you return true. Same thing here. If you get to the end, it's just how we think about getting to the end is a little bit different. Here you're iterating, right? I++ to check the next element in the list, right? And here you're recursing and saying, I'm going to run this function on the rest of the list. Now, so hopefully this line of thinking is getting more familiar for you. Okay, we're out of time. I'm saving these files so that I can post them on the site, and of course we'll post the video. If you have questions, put them in the discussion boxes on Canvas.
When should the homeworks be graded?
I don't know. I know Michael's been working on that, and I know, like all of us, he's kind of swamped. So I'm not sure. I'm getting through the reports bit by bit. I think I have 2/3 or so of those graded. So I'll do the reports, and when I'm done with those, like with the programming assignments, I'll start helping out with those too.
Okay.
But I'm not sure. You can always message him. And by the way, if you guys have questions about the class, please use messaging in Canvas, not email. If you have to get in touch with me outside of class stuff, email is fine. But I'm trying to contain all my communication channels here. So if it's related to the class, Canvas, please. All right, we're really out of time and some of you have to go. Take care.